series of careers related videos, and today I have some guests with me from Cheesmur Building Contractors. We've got Steve, Dan and Jen, and they're here to talk to you about the importance of maths in the construction industry. So a question I know our maths teachers at Hailsham Community College often get asked is, when am I ever going to use this outside in the real world or in a job? So we've got the perfect opportunity here to hear from three employees from a local company in East Sussex, and this video is brought to you in partnership with East Sussex Careers Hub as well, and will hopefully be shared with the other secondary schools around the county. But I'm just going to throw that question out to Steve, Dan and Jen and say, could you let us know, how do you use maths in construction?
Okay, I'll start. So yeah, maths is, I think, used in all the aspects of construction, you know, in the office and as well as on site. I work in the accounts department, which is obviously very number heavy. So my day-to-day role, I'll use maths quite a lot in, you know, calculating payments, payments to suppliers, salaries. We also, you know, need to know how to work out percentages quite a lot for working out there. You know, there's a construction industry tax, so we need to work out what we need to deduct from our subcontractors. Also for working out like retentions on jobs, which is where we hold back a certain percentage for a period of like 12 months to cover defects on a job. We also use kind of a lot of sums during in our for spreadsheets, for example, working out and comparing budgets and forecasting. I'm sure there's yeah, a lot more complex maths used in other areas of the business that you guys will know a bit more about. So.
Yeah, I mean, I could jump in. So I'm an estimator for Cheesmur. So an estimator, we try and secure a lot of our work through competitive tendering, which basically means how much is it going to cost for Cheesmur? How much are Cheesmur going to charge us to do this job? So I work that out for lots of different jobs, and the majority of my day is spent using maths. So more often than not, I've got a drawing or a set of drawings for a project. So I'll need to work out the floor area, for example. So I need to have some understanding of geometry and how to work that out. Not every building is square, so it's not just a case of, you know, X times Y. It's you know, you've got to take some circles, you've got to take spheres, and you've got to 3D that as well. So sometimes you're trying to work out the cubic meterage of, say, some excavation. So there's a lot of the sort of basic stuff that way. And then you can compound that with, so with excavation, for example, if you dig 3 meters cubed of soil out the ground, when it comes out the ground, you have to get rid of it. But when it comes out the ground, there's a thing called bulking, which is what you take out actually takes up more space once it's out the ground than it did in the ground. So you've got to add 15%, 20%, whatever, depending on the ground, to that. So there's a lot of geometry, there's a lot of percentages, there's trigonometry if you're cutting and pitching a roof. Sort of, if you picture in your mind your typical sloping roof, you've got lots of triangles. So you've got the areas of the triangles, the angles of the triangles. So it's everywhere, absolutely everywhere. My job is predominantly maths. I'm quite lucky. I really enjoy maths. But I think it's important to point out that it's not just the arithmetic side of it. So a lot of it's the processes. So you may very well be able to work out 4 times 3. That's nice and easy. But you need, so that's the arithmetic side of it. But the math side of it is understanding when you need to use 4 times 3. So if I showed you a picture of a square and said, what's the area? You can work that out nice and easily. If I showed you a picture of a complete house and said, what angle is that roof, for instance, you'd have to understand what sort of maths you need to use to get to it. So yeah, it really is everywhere in my job.
It's quite important as well, because if you guys make a mathematical error somewhere along the line, that could lead to quite a big problem, couldn't it?
Yeah, it could be costly. So if I'm plugging some numbers into my calculator and I hit the wrong button, having a sort of intrinsic understanding and a rough idea of what it should be.
Yeah.
If I suddenly look at that calculator and think, wow, that's £50,000 more expensive than I was expecting it to be, I've then got to be able to look at the maths I've just done and spot the mistake if I've put the wrong number in, if I've used the wrong equation, if I've used the wrong sort of theorem to get to it. Yeah, it's absolutely everywhere. It's more a case of what maths from school am I not using, because I'm using more of the stuff I learned than not using it, if that makes sense. Steve?
Yeah, so from my point of view, I'm a director, so I look at the information that Jen and the rest of the accounts team and Dan and the rest of the estimating team prepare, and also the figures that are given to me by the guys on the production side. So the quantity surveyor, which is what I started as. So if Dan has priced a job, we send that price into the client. The client's team are having to compare the prices with other prices they've had from other contractors, other builders, and they have to make a decision what is the best one for them. So they have to analyse all our prices as well. So knowing that, well, hang on a minute, so Cheesmur are more expensive, but their costs for the heating systems seems to be disproportionately high compared to the other companies, and they're able to do that compare across a part of that document that Dan sent in, come back to us and say, are you comfortable? Have you made a mistake? And it's being able to analyse. So you've got a long list of figures with a long list of descriptions and go through and highlight what's required. But the most important thing when people talk to me about maths in schools is money. I always say that, you know, for any construction project, the first thing you need is money. Unless you've got money to buy the land or buy the building and pay for the work to be done, you can't do it. So you need the money. You need to be able to understand money. And in our industry, as Jen said, there's a lot of percentages being deducted. As Dan said, there's understanding. So Dan just talked about digging and taking soil out of the ground, and then the fact that it bulks up. So you've got that knowledge of construction, that you know that when you take soil out of the ground and you dig a hole, you've got the soil takes more space when it comes out of the ground than when it's in the ground. So you know that, and then you've got to apply the maths to calculate. And Dan talked about the roofs as well, and I won't get into the trigonometry, but that's quite complex. But going back to the money, you know, when you leave school and you go into your first job, you need to know what you're going to be paid. And if you're going to be paid by the hour, you need to be able to understand how many hours you've worked when you fill in your timesheet and what you're going to expect to be paid for those hours. And if you're doing overtime, which might mean you get 1.5 times your salary to do overtime, you need to be able to calculate that separately. Then when people like Jen do your pay slips and you get your advice of how much you've been paid, you need to understand, right, well, I did this many hours, I did this many hours overtime, my earnings were this, say it's, I don't know, 500 quid, for example. I've got £500 income for that week, but they've deducted tax and national insurance and my pension contribution and anything else. And you need to know how that's calculated so that when you check your pay advice that comes through to you, that you've been paid the right amount. Mm-hmm. That's very important. And similarly, when you've got your own house or flat or whatever, and you're paying the electric bill and the water bill and you're paying for the insurance, you need to make sure that you're paying the right amount and you're not being overcharged. You need to be able to calculate what your meter reading is. And I know that's basic arithmetic, but it's that understanding. Just once you understand those things, you can apply that to so many things, not just in the construction industry. But yeah.
Can I just jump in on something you said earlier, Steve, just before I forget? You were talking about keeping records and etc. So I remember from school being told to show my working, and not really understanding why. If I knew what the answer was, why did I need to show my working? So a lot of my job, when I submitted costs, I might not hear about that job for another 3 weeks, and suddenly I get an email that says, I see you've got a rate in for this item of £5,000. Why is it £5,000? I can't remember that job, it was a month ago. So what I have to do is go into it and find it, and if I've just got 5,000 written in there, I've got no idea. I have to go through the whole process again to work out why. But if I've got my working in there, I can see, oh look, well what I've done is I've got 4 man days for 3 electricians, and they've got these materials, but I've times it by 150% because it's Saturdays, because it's overtime, and I've divided it by this because one of them's an apprentice. That's how I got my £5,000. So the whole showing your working thing, yeah, it just occurred to me as Steve was talking about keeping records. It is really important, and you do use that in life, or if you don't use it, it's really, really hard. Makes life much more difficult if you've forgotten to write it all down.
That's a really valid point, really useful.
And the other thing going on as well, I mean, we did receive a very good question from one of the students about a thing called BIM modelling. And BIM is Building Information Modelling, which is like 3-dimensional computer programs where you can look at the drawings that Dan's talking about, are 2-dimensional drawings, and it's for plans and elevations and all the dimensions in the building, and the program will produce on the screen a 3-dimensional view of that building. And nowadays they've got these programs where you can actually walk through the building before it's even been built. It's been modelled in 3D, and that's the thing called CAD, Computer Assisted Design, which is part of the building information modelling. They use CAD for building information modelling, and you know, people have to design that. People have to write the programs for that to be able to function. That is something that maths is very important. If you want to do anything with computers, you need to have an understanding of maths and IT. And the other part of that is a lot of the designers now, the architects and the engineers, for example, they use that software, for that CAD or BIM modelling software, to design their building. So you've got to have an understanding. Going back to Dan's point, if you're using a computer to set out the footprint of the building, and a classic point, I used to work overseas, and we in UK measure in millimetres, and we came across a lot of French and French Lebanese designers, and they were used to working in centimetres. And you had to be very careful when you were clarifying what they were asking you to do. You know, if they were asking me for a 60 by 60 piece of wood, well, I'd be making a tiny little 2.5 inch piece of wood, and they're talking about a 2 foot by 2 foot piece of wood. And it's understanding that, you know, somebody's asked me for a 60 by 60 piece of wood. Why would they ask me for that? It's not sensible. So you're applying logic and common sense. And making sure the maths is correct. I'm not sure I've got much else to say on that at the moment.
What about, so you're a director, so some of your business decisions, I presume, are based on some mathematical sort of input, not necessarily arithmetic, but so I don't know if you'd have come across the prisoner paradox in your studies yet, but things like that, if I'm submitting a price and I think it's £50,000, and I know that 2 other competitors are submitting prices and I think they're going to be about the same as mine, I have a decision to make. So I want to make profit on that, but if I put 50% profit on it, are they likely to put 30% profit on it and win the job because they're going to be cheaper? So I have to work out if they're going to be thinking the way I'm thinking, and so this is all maths, it's just not arithmetic. So, and the same goes, as I say, director level decisions. If you're looking at your competition and you know that your turnover is X and you think their turnover is Y, you know, are you going to have to take more staff on? Are you going to have to take fewer staff? Are your costs going to go up, or are they going to go down? Do you think you'll lose work to them? Like, these are all maths based questions. Just because it's not, you know, find X given Y, it's you know, that the underlying principles are mathematical principles. So if the more you understand maths, the easier and the more chance of making the correct decisions you're going to have going through your career, because you know, you don't know, you might end up being a director of a construction company and suddenly, you know, you wish you'd listened and you knew about scale drawings.
Yeah, if you've got to be a director, you should know about scale drawings.
Yeah, hopefully by then.
But that's a valid point. So without getting to a high level, so we take Dan's point, we have to look at the market and look what we think the market is and how we, you know, we're always looking to make things more efficient, more sustainable, safe for delivery, particularly in the COVID-19 pandemic, making sure it's done safely. And one of the things, or two things we have in our business, is a turnover forecast. So we have a forecast for the next 6 to 12 months of what we think we're going to do, what value of work we think we're going to do, and where we're going to do it. And then we can work out what resource we need to do that work. We can forecast that. And then we have a thing called a cash flow forecast, which is a big spreadsheet. But in simple terms, going back to when you've got your own house and flat, you write in how much money you've got coming in at the end of every month, and you know how much you're going to spend on electricity and water and the rent and the insurance and all those things, and running your car and fuel, and how much you're going to spend on food and how much you're going to spend going out on a Saturday night. You should be able to work out, are you going to have some left over at the end of the month, or are you not? So in simple terms, just making sure you can manage your own finances on a bigger scale, a much bigger scale. And we're a smallish business. We employ 65 people. You know, some of these big multinational companies employ thousands and thousands of people, and they're doing that same thing, but on a massive scale. And the other thing is, which is important, when you start earning money, is you will get a credit rating. And that credit rating is based on algorithms, based on your behaviour in terms of money in, money out, paying your bills. And that's all maths. And so you need to understand that, because if you want to go to the bank for a loan or a mortgage to buy your first property, those algorithms will make the decision for the banks or the lenders as to whether they're going to give you the money. Yeah, it's whatever you do, it's maths. It's
I was
maths.
just thinking about what Dan was saying there about the other companies putting in bids. Is that a bit of probability in there as well around kind of what they would? Is there elements of that? Just thinking back to my old GCSE maths, and it just sort of sounded like that kind of, you know, sort of foreseeing a little what others might do and how that lies.
Yeah, so sometimes if I'm putting a bid in so obviously sometimes you bid on work that you're less keen on than others, but let's say I'm particularly keen to win one and it's with a consultant and client I've bid on work for before, I might look back at the other jobs we've done for them, had a look at on average how much competition there was. So if I'm sending it in and I know that there have always been 5 submissions for it, I know that I've got to beat 4 other people, so I'm 1 in 5 already. So that's going to influence my you know, whether I'm trying to put lots of overheads and profit on it, whether I'm trying to, without sounding crass, trying to make as much money on a job as possible, or trying to make just about enough money to win it, or what. So yeah, there's definitely probability involved. That's that side of things. Just one little point I was going to make, Steve was mentioning, if you haven't started using Excel as well, it's a really, 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 really useful tool for the whole construction industry. And the majority of it is putting formulas together, and those formulas follow mathematical principles. So because I enjoyed and paid a lot of attention to, and still do learn as much as I can maths wise, I don't feel like I understand Excel very well. I use it well because it's just, as far as I'm concerned, it's just putting mathematical formulas in. And that's been invaluable for the last 6 years. So yeah, if you're looking to get into construction and you haven't, I would start using Excel a bit, which is just maths. Again, it's just maths.
And interestingly, again, during the COVID-19 pandemic, you've been seeing a lot of graphs in the news.
Yeah.
A lot of graphs. And we use those graphs. So I talked about a cash flow forecast. We can feed that data into the Excel spreadsheets Dan was talking about, so we know what's coming in, what's going out. We can forecast what's going out, and that we can convert that within that Excel spreadsheet into a graph, and it paints a really easy picture to understand where we're going to have a problem, and it highlights, forecasts any problems. And that's a really useful tool, because it's one thing to just look at numbers on a spreadsheet, but the minute you look at a graph, you know, there's an old saying, a picture paints 1,000 words, and it does. You suddenly go, well, hang on, why are we going to be short of money during that week in August? Are we going to be able to pay everybody? And if it's going to be a problem, we can start making plans now based on that forecast. Now, which again is quite relevant to the current situation, but I'm not going to talk about anything political today.
Well,
but
just on the back of that as well, so this companies that we all work for is still going because the directors have made decisions based on information they have modelled in graphs, and they have understood the graphs, so they've made the right decision. It's all very well being able to make a graph, but if you don't understand what you're looking at, so if you don't know the difference between correlation and causation, you might take a few bits of information and draw a line through the middle of it and think, oh well, look, well that's fine, because in 3 years time, according to this graph, we're going to have 20 billion pounds in the bank, so that's great, we don't need to do anything. I mean, I'm going a bit extreme, but if you misinterpret the information that you've got because your maths is bad, it's not just you're not just going to get a little red X by your calculation. You might not have a business to work for next month. You know, you might not have a job. 100 people might not have a job next month because your maths wasn't good enough to understand the information that you've had presented with you. So it's not just the day-to-day decisions, big decisions that are being made. So Steve and the other directors, for example, they're making these decisions because they understand the information. And if they didn't understand the graphs that was presented to them, we wouldn't be here telling you this, because we'd be working elsewhere. Is that a fair comment?
Yeah, it's a very valid point. So for using COVID-19 as an example, so I'm sure most students know about or have been affected by the furlough scheme. You know, we had to look at what work we were able to deliver, what work we couldn't deliver, what resource we needed to deliver that, including what staff we needed, and then took the decision to some staff furlough to ensure that they didn't lose their jobs, but to also ensure that the company could continue trading in the short to medium term, so that there is a job for people to come back to, and planning ahead. And we are looking at that data. Well, in the first month, we were looking at it more than once a day because things were changing so quickly. And as Dan said, by getting all that information and feeding it in, it's been very useful. And it's not just us. Companies all over the country and all over the world where they've got similar schemes running are doing the same thing.
And it's all numbers and stats and maths.
Yeah, it's all numbers,
basically.
Statistics and maths. And as a result, we can see where what we call the pinch points are. Where are we going to be tight for money? And if we are going to be tight just for that week or 2 weeks, the company can still carry on trading as long as we've got strategies to manage that situation and just tide us over.
It's everywhere. It's ubiquitous in this industry, isn't it? Maths is.
Yeah.
That's fantastic. Thank you so much. That's really, really insightful, and I think it's really valuable for our students to actually see that there's an application behind what they are learning in school, and that, you know, not just in construction, as you say, but so many jobs, maths is so important, and in those life skills, like you mentioned, Steve, as well, in terms of your own salary and running your own home. So yeah, just really great to hear from people other than the teachers about why this is so important. So I really thank you for your time. It's been really valuable video. I look forward to sharing it with the students at Hailsham Community College, and I think the Careers Hub will hopefully be sharing it further afield as well. And I'm sure it won't be just year 10 that are impacted by all your words. We'll be sharing it further afield too. So thank you very much for your time. I really appreciate it.
Thanks, Jenny.